Hi guys, welcome to another teardown video. This time we're taking a look at Razer's optoelectric switches, Light Strike Libra. I've got some examples of the clicky and dampened linear ones here that I'm going to show you how they work. Optoelectric switches work using a very simple principle. You take an LED, in this case an infrared one, and you put it opposite a photoresistor, which is a resistor that's sensitive to light. When light shines on it, the resistivity decreases and it permits more current to move through. The switch itself is in essence nothing but a device that keeps a shutter between the two, and when pressed moves the shutter out of the way so that the resistor can see the LED opening the circuit. This allows optoelectric switches to have very few moving parts and even fewer ones that cause friction, making them very smooth, as well as affording them extremely high reliability, generally limited only by the lifetimes of the LEDs or photoresistors. The switches are extremely difficult to take apart, so I cut the sides off of two of them so that you could see how they work. I left the springs out too, which are non-MX compatible by the way. In this linear one, you can see that the slider simply moves up and down, assisted by inner and outer guardrails. As you can see, when I lower the slider, a tiny hole becomes visible through the switch, which is the viewport between the LED and the photoresistor. The LED and photoresistor are held PCB side, and the switches just slide over it, held in place by a mounting plate. Technically, the output is analog, and some of Razer's specialty stuff uses slightly modified version of these switches with analog output, but in order to suppress costs, their keyboards generally use simple digital interpretation. It's off beneath a certain exposure and on above it. The original LK Libra switches were just linear, but these new ones include rubber dampeners in the slider, which you can see here. The contact points are here at the bottom and up here in the armpit, so to speak. These dampen impact with the piece of plastic that's normally here, softening the sound that the switches make. The clicky ones don't have dampeners but use a very intriguing system to generate the click. Instead of the click jacket that MX type switches use, which use the friction between the jacket and the switch contacts to store energy, the Libra switches use a click bolt, partly because this allows for less friction in the design, and partly because the Libra switch has no contacts for the jacket to rub against. The bolt is a two-pronged plastic implement that looks a bit like a tuning fork sticking out of the bottom, and is rotation locked via this little cam track here at the top with a following peg in it, and this bolt is spring-loaded via a spring held captive in the slider, so as you push the bolt it is rotated around its axis. This interacts with the cam track in the bottom housing of the switch, which, and I'm really happy now that I bought those macro lenses for my camera, consists of a flat-backed plateau with a drop at the end. The track is mirrored, both prongs get one side of this track. The idea is that the fork gets rotated along the plateau part of this track until it reaches the drop part, at which point the fork is allowed to shoot downward. Because the bolt is spring-loaded and pushes against the downward motion of the key, the jumping down of the bolt is felt as a release of pressure, which is what makes up the tactile event in the switch, while the sound of the bolt slamming down is the clicky noise. Unlike the linear version, which is analog capable, as I mentioned before, the clicky version opens at once when the bolt is allowed to drop down, so this design is digital only. The switches all come with their own integral stabilizer, which is a wire stab held between a recess in the housing and two rails in the slider. Curiously, unlike most other systems that work like this, it doesn't rattle. Also, at the top there is a little clip-in plastic dome-shaped light pipe for transmitting backlighting to the top and distributing it. All in all, it's a highly interesting design and of comparative complexity for an optoelectric switch. The dampened linear ones have 7 parts: the housing, the slider, the 2 dampeners, the light pipe, the stabilizer wire and the coil spring. The undampened linear ones are the same, minus the dampeners of course. The clicky ones also have 7 parts: the housing, slider, click bolt, captive spring and coil spring, the light pipe and the wire stab. Hope you enjoyed this video guys, and see you in the next episode.